Hello learners, and welcome to today's lesson of Geometry of 2D Shapes, Quadrilaterals. Now let's start off our lesson with a did you know. So did you know that a rhombus is a special kite? Yes, when we look at all the properties of a kite, they also describe what a rhombus is. This lesson is going to give us more details on this fact. Isn't that interesting? So let's see how this is possible. So let's look at the lesson objectives for this lesson. By the end of the lesson, learners will be able to write clear definitions of quadrilaterals in terms of their sides and angles, distinguishing between a parallelogram, a rhombus, a trapezium, and a kite. The concept map for today's lesson, of course, the focus being the geometry of 2D shapes, quadrilaterals, we are going to look at those quadrilaterals mentioned, which is the parallelogram, the rhombus, the kite, and the trapezium. So for this lesson, you must be able to identify the different types of quadrilaterals and their properties in terms of their sides. So let's look if we can identify those quadrilaterals. Now, the first one here is a parallelogram. And what do we know about a parallelogram? Well, firstly, from the name parallelogram, we know that there are sides that are parallel. Now, which sides are these? These are the opposite sides, the sides that are non-adjacent. So one pair of side is parallel, and of course the other pair of opposite sides is also parallel. So we have two pairs of opposite sides and they are parallel, therefore a parallelogram. What else do we know about a parallelogram in terms of its size, in terms of the sides? Now we know that the opposite sides are equal. So, of course, that is the symbol that we use to show that these sides are equal. So now we know that AB is equals to DC. What else do we know about the sides? Yes, the other two opposite sides are also equal as well. So what do we gather from a parallelogram? Well, firstly, we know that AB and DC, they are opposite each other, and as they are opposite each other, they are first of all parallel, and of course AB and DC are also equal, and that is because it is a parallelogram. Then we have AD and BC, and what do we know about AD and BC? They are opposite sides. Yes, they are parallel, and they are also equal as well. So we have two pairs of opposite sides and we have two pairs of parallel sides. That is a parallelogram. Let's move on to the next quadrilateral. Next, we are going to be looking at a rhombus. Now, what do we know about a rhombus? Now, a rhombus is a parallelogram that has all of its sides equal. Now remember, with a parallelogram, we just had the two opposite sides that are equal, the sides that are non-adjacent, but now we have all of these sides to be equal. Let's look at those properties, each of them. Well, firstly, because we did say it is also a parallelogram, we can see that we have a Kn that is parallel to Lm. And we also have Kl also parallel to Nm. So again, we have those opposite sides that are parallel each other. Then we have the equal sides, which is of course again Kl, which is equal to Nm. And we have the other two opposite sides that are equal, which is Kn and Lm. But remember, we said this is a parallelogram that has all of its sides equal. So that means that as much as Kl is equals to Mn, but Nm is also equal to Kn, and that of course is also equals to Lm. So all of the four sides are equal. Let's move over to the other quadrilateral, and that is our kite. Now, what do we know about a kite? We definitely know that it is a quadrilateral, but what is special about a kite? Yes, we have the adjacent sides to be equal. So we have SV, which is equals to ST. And those two sides, they are adjacent to each other and they are also equal to each other. We also have the other two adjacent sides that are equal to each other, and that is VU, which is equals to TU. Now, it is not all the adjacent sides that are equal to each other, but it is only two pairs of adjacent sides that is equals to each other. So in this case, that is VS with a TS or SV with ST. And then we also have then our VU with our TU. And those are the adjacent sides that are equal to each other. What else or which other quadrilateral are we going to look at? If you are thinking of a trapezium, then you are absolutely correct. Now, what do we know about a trapezium? Well, a trapezium, we know that we have one pair of opposite sides that are parallel. So that means here that WX is parallel to ZY. Yes, and that is when we have a trapezium. Of course, we also have an isosceles trapezium, which we are going to look at in more detail later on. But when it's an isosceles trapezium, then we also have two sides that are equal as well. But we can look at that later on in our lesson. Let's move over to the keywords that we are going to be using during this lesson. So we are going to be looking at a quadrilateral, and that is a polygon with 4 sides. Then we are going to be looking at diagonals, and that is a line segment joining two non-adjacent vertices of any polygon. Then we are going to be looking at bisect, which means divide a line, an angle, or a shape, or any object into 2 equal parts. Then we are going to be looking at a parallelogram, and that is a quadrilateral with 2 pairs of opposite sides that are parallel. Then we are going to be looking at parallelogram. This is a quadrilateral with 2 pairs of opposite sides that are parallel. Then we are going to look at a rhombus, which is a parallelogram with all 4 sides equal. Then we are going to look at a kite, which is a quadrilateral with at least 2 pairs of adjacent sides that are equal. And lastly, we are going to look at a trapezium, that is a quadrilateral with at least 1 pair of opposite sides that are parallel. And those are the keywords that we are going to be looking at during this lesson. Now, let's quickly go for an ad break, and then we'll see you just now.